Welcome to a lesson on finance. So, a couple of weeks ago, towards the start of the holidays, there was some talk of holiday classes and people wanted to catch up and revise content, I guess. And I offered to, we can have ourselves a mini ConquerHSC holiday program ourselves. And some students showed some interest, and especially on finance and stats. That seemed to be the common request. So here's the first lesson. I put together this document. Hopefully it helps someone. So let's get started. Okay, so the first thing, I want to break this up into 6 lessons. Compound interest, annuities in general, what are they? Annuities and tables of future value. How do you figure out annuities if you have a table? And then we'll do investments. Then we'll do reducing balance loans, and finally we'll end up with effective annual rates of interest. Okay, alright, let's just get started. So today's lesson is going to be on compound interest. Now I'll leave the reading on the syllabus dot points to you, just to save time, I suppose. But my interpretation, if you read that, my interpretation is you have to learn compound interest. Simple as that. You just have to learn it. Now, interestingly, simple interest is not mentioned in the syllabus at all, and neither is depreciation, so I'm not going to cover those. I'm sure your textbook covers it if you want to have a look at them for revision purposes, or just to cover your bases or whatever. So I'm just going to stick to the syllabus dot points. For each section, for each lesson, I've looked at the syllabus carefully, and I've split up the syllabus dot points into lessons, and that's all I'm going to cover. Alright, so let's get started. So we have A is equal to P, 1 plus R to the n. That is the basic formula, and I'm sure you will have used this pretty much throughout high school. But yeah, I mean, it is in the HSC, might as well cover it. A is equal to P, 1 plus R all to the n. Now, what does A mean? A means the total amount. So it'll be the principal, the money that you start off with, plus any interest that you accumulate. So it's the total value after you finished compounding, after you finished adding interest. Now it's important to note that because with the simple interest formula, it's actually not the case. I equals PRN. That's a simple interest formula. That only gives you the interest. I is the interest only. So it's good to be aware of this. The difference between this. This gives you the interest only, but for the compound interest, it gives you the principal and the interest after you've finished adding the interest and so on. Just be aware of that. And then you have P, principal. I like to think of it as the money that you start off with, the money that you're going to compound, the money that's going to gain compound. Okay, so I'll define it really simply. In common language, right, it's the money you start with. I'm sure technically it might be slightly incorrect or whatever, but P is the money that you start with, the money you start with. And then you have 1 plus R. R is the interest rate. Interest rate per period, per time period. Now, with simple interest, compound interest, annuities, and so on and so forth, it's important that you match the interest rate per time period. You match it with the compounding period. And you match it like this R and this N have to be in the same time unit. The interest rate can't be per year and then N in months. It doesn't work that way, okay? R, whatever time period you use, if it's per year, per month, per week, whatever it is, N has to be the same. And with compound interest, you need to match the compounding time period. So if it's compounding every month, then R has to be in months, and N also has to be in months. Really, really important. Yeah, I just can't stress that enough. So N is the number of compounding time periods, the number of time periods. Number of time periods. And I'm sure this will be revision for most of you. Feel free to skip ahead, look at the questions if you want, or just wait for lesson 2, lesson 3, and so on and so forth if you're comfortable with compound interest. But I am just going to cover all the syllabus dot points. So I'm sorry if this is really easy and basic stuff for you. Just bear with it. And look, you can always skip it. It's not compulsory or anything. But yeah, I'm covering it just in case someone needs help with it. Someone didn't quite get it when they did it at school in the previous years or whatever. I'm just doing it anyway. All right. So I've covered that. Now, just need to be aware, as I said earlier, that A is the money that you'll end with. It's not the interest. If you want to find the interest, interest is going to be the money you end up with minus the money you started with, right? A is the money you end up with. P is the money you start with. So if you subtract the two, if you start off at 10,000 and you compound and you end up getting 15,000, what's the interest? Well, the interest is going to be 15,000 minus what you started with, 10,000. So you have to subtract the two. Just subtract these two to get the interest only. Interest only. All right. Now, sometimes some alternative notation you should probably be familiar with. Sometimes you'll see this FV. FV simply means future value, the money in the future, and PV means present value, or the money you start with, I suppose. Just be aware, it's the same thing as this is just A, and that's just P. Future value, present value. You start to use it in annuities a fair bit because obviously it's not principal anymore. But we'll get to annuities when we get to it. Okay, so don't worry about it for the time being. Just know FV is equal to PV. It's just alternative notation, means the same thing. Nothing changes. All right, next thing that you need to know is that the basic compound interest formula has 4 variables. So, as I'm sure you can see over here, it has A, P, R, N. So any of those 4 could be missing, and they will always give you the other 3. And then you just have to figure out the missing one. So you have 4 different basic archetype of questions. Okay, so here's the first one, question 1. Ibrahim invested $4,000 into an account with interest rate 6% per annum, compounding monthly. If Ibrahim leaves the investment for 8 years, what amount does the investment grow to? Hence, calculate total interest earned. Okay, so I always like to start off with the formula. Regardless of what topic you're doing, you should always start off by writing down the formula. Sometimes you even get marks for it. Even if you get the rest of the question wrong, sometimes you'll actually get marks just for writing this down. So why wouldn't you? Honestly. Okay, so start with this. Now, Ibrahim invests $4,000. That's what you're starting off with. That's what you're investing. So that's clearly P. Interest rate of 6% per annum. That means per year, but it's compounding monthly. So we have to convert that so it matches the compounding period. So 6% is for 12 months, and we want it in 1 month, so we're just going to divide by 12. That'll be 0.5%. 0.5%. Now, anytime you see a percent sign, you can wipe it off and put it over 100. Just do this. Make it a habit. Just do it. Even if you're really good with decimals, just avoid the chance of a silly mistake. Don't work with percentages, and don't try to, that's just what I teach my students. Don't try to work with percent signs. Do not use a percent sign on your calculator. It has weird and wonderful things. You don't want to mess with it. Just convert to a fraction straight away, and you'll never go wrong. 0.5 over 100. That's R, okay? R is 0.5 over 100. And let's move on. Leaves investment for 8 years. Well, that's N. Number of time periods. Hang on a second. Is it 8 though? It's not 8 because it's 8 years. But we're working in months. So 8 times 12. That is not N. N is 8 times 12. And 8896, but just in case you can't do it mentally, 8 times 12, 96. N is 96. Okay, so N is 96. So we're just gonna substitute into the formula and just see how it goes. What amount does investment grow to? Hence, calculate total interest earned. So we'll have to do 2 things. So let's just get started. N is 96. Let's keep that in mind. So A is equal to, N is equal to 96. I'll just leave that on the side. What's P? What do we start with? $4,000. 1 plus R is 0.5 over 100. All to the power of N. Now N was 96, remember? 96. And we're pretty much done. So just put all that in the calculator. 4,000, open bracket, 1 plus 0.5 all over 100, close bracket to the power of 96, and 6,456. So 6,456. 0.57, 57 cents, I suppose. When you're dealing with money, just always round off to 2 decimal places unless it tells you otherwise. Definitely don't do 3, 4, 5 decimal places, obviously. The question will either ask you for the nearest dollar or the nearest cent as a general rule. Over here it doesn't really say anything, so I'm going to write to the nearest cent. So 57, yeah. Alright, now that's what amount does the investment grow to? $6,456.57. Hence calculate total interest earned. Well, we started off with 4,000, right? So I is going to equal to A minus P if you want to use the formula. This is the money you start with. P is the money you start with. And so it's going to be 6,456.57 minus the $4,000 you started with, leaving you with $2,456.57. Okay, so yeah, pretty straightforward. Moving on. Find the rate at which an investment grew in percent per annum. So that's we have to find R. R is going to be missing. If the original investment was $20,000 and grew to be $35,000 in 10 years' time. Per annum. So we're working in years. That makes it a lot simple. I guess this is an easier question, but let's just get started. A is equal to P1 plus R all to the N. Now we can substitute what we know. Original investment, that's clearly P. And grew in value to be 35, that's A. 10 years time, that's N. And we have to find R. So we know A is 35 is equal to P was 20,000. And so we have 1 plus R to the N. N is 10. Alright, so we're going to divide both sides by 20,000. So it's going to be 35 over 20 is equal to 1 plus R all to the power of 10. And so to get rid of a power of 10, we have to take the 10th root of 35 over 100. So the 10th root of 35 over 20 is equal to 1 plus R. And so R is going to equal to the 10th root of 35 over 20 minus 1. And we can do it on the calculator. So the 10th root of 35 over 20 minus 1. Just be very careful with the make sure this looks like that, I suppose. And so we have 5.76%. R is 5.76%. Now that's a decimal. So if you want to convert it into a percentage, and you generally should give R as a percentage, you can multiply this by 100. If you can't do it mentally, that's fine. Just do it, multiply by 100. You multiply a decimal by 100, you get a percentage. Okay, so 5.76%. It doesn't say round off to anything, but I'm going to round it off to 2 because why not? All right, so that's how you do R. And look, they're going to be fairly standard. These are like archetypes, and questions will either have A and I, like they'll ask you to find A and I. They'll ask you to find R, like this question, or they'll ask you to find N. And there's a slightly different approach to each of them, slightly different. The key over here really was taking the root, the 10th root. In my experience, this is where students stuff up. They get this, and they're not sure what to go from there. To undo power of 10, you take the root, 10th root. And over here, that was pretty straightforward. That's honestly, that's just calculator work. And let's see how we'll do N. So we'll move on to the next bit. Yeah, so once again, the root, the key over here was taking the 10th root, taking that root. Whatever that power is, take the root, and everything else just works out. It's pretty straightforward. All right, so wiping this off, and let's get started with the next bit. Finding N. How long will it take for $20,000 invested at 5% per annum to reach $35,000? Okay. How long will it take? That tells you straight away that it's N. $20,000 invested at 5% per annum. That's P. That's R. And that's A. That's going to be the final value, 35. You're starting off with 20,000. So let's write our interest. A is equal to P. 1 plus R all to the N. Now, you know what A is. So we're just making the substitutions. Is equal to P, which is 20,000. 1 plus 5% per annum. It's all in annum. N is going to be in annum as well, so it's per year. It doesn't give us any more information about compounding per month or whatever, so we're just going to work in years. 5%. Anytime you see a percent sign, wipe off the percent sign, put it over 100, you'll never go wrong. And we have to find what n is. Well, we'll start off by, dividing the two. 35 over 20 is equal to 1. And look, 1 plus 5. I know it's 1.05, but in case you're not sure, 1 plus 5 over 100. And it'll give you 1.05. So for the sake of simplicity, 1.05 all to the n. So how do you solve this? Okay, so here's a tip. Anytime you have the variable in the power, okay, so you can see over here, the variable, the missing variable, the thing we're trying to solve is a power. It's always going to be a logs question. Off the top of my head, I cannot think of any other way to solve this. It's pretty much always going to be a log question, okay? That's power. And it's that's a power. The variable is a power. You have to use logs. There's no other way. And pretty much throughout Maths Standard, Maths Advanced, and even 3-unit. In fact, as far as I know, anytime you have a variable in a power, it's always going to be solved using logs. So let's just take the log of both sides. Now you can take log base 10, log base e. It doesn't really matter as long as you do it the same. I'm just going to write log, and you can use whichever one you want. 35 over 20 is equal to log of 1.05 to the n. And the reason why logs works is because of the log law. If you have log b to the a, then that is equal to a log b. You can bring the power down. That's one of the log laws. And that's why it's so useful. We can bring the n down now. So we're just going to be, that's going to be the same, is equal to n log 1.05. And now we just divide the log 1.05 out. So you will have log of 35 over 20 all over log of 1.05 is equal to n. And on the left, it's just calculator work. So once again, be very careful using the calculator. Make sure the expression you put in is exactly what you see over here, what you have over there. 35 over 20. And there we go, like this. So we have log 1.05. You would not believe how many times when I mark students' works, that they just get this step wrong. Just putting into the calculator, they get it wrong. Just be very careful. Make sure you know how to use your calculator. Be very familiar with it. And yeah, so it's 11.47 and is equal to 11 and is equal to 11.47. So what was the question? How long will it take for $20,000? Blah blah blah. All right. So how long will it take n? Now remember, we are working in years. So 11.47 years. I would answer that. I would accept that as an answer. 11.47 years roughly. And remember, we did estimate. I should have been a bit more careful actually in previous questions as well. Anytime you estimate, you must always write is approximately equal to. Don't write is equal to. That's incorrect. All right. Moving on. Finding p. So that should be probably one of the easier ones. And yeah, so once again, when you're trying to find n, the key really is the logs bit. Yeah. So just be aware of that. And look, if you're not good with logs, do logs. Right? That's another thing that I've noticed with students. Students frequently avoid the topics they're weak at. Whereas in reality, you should be focusing on the topics you're weak at. Because that's the stuff you have to learn. That's the thing that's going to stuff you up in the HSC. So even with your subject, I've seen students who are good at English and they just write essays all day long. Like every day they're writing a new essay, but they're poor in maths and they're not doing the maths. So that's not really a solution to anything. If you're weak in something, that means you should be focusing on it. Focus on your weaknesses. That's how you do well. You have to do equally well in all your subjects for your best ATAR. That's just some general advice regarding your ATAR. Focus on your weak subjects. And I speak from my own personal experience, right? I had one subject which I did really poor in, and it really affected me. Really affected me. So honestly, just take my advice. Play around with the ATAR calculator if you're hesitant about my advice at all, and see for yourself. If you get, like, for example, 90, 91 or 85 in all your subjects, see how you do. And if you get like 91, you get like, 86, 85, 84, and one subject you get like 60 or 70 or something, see how much worse the ATAR is. Play around in an calculator, you'll see for yourself. My advice, Be equally good in all your subjects as much as possible. There's no point, spending hundreds of hours moving up from a 90 to a 95 in one subject, and the rest of your subjects you're getting 80s and 75s and so on. It's far better to get like 85 in all your subjects. Obviously, the better you do, the better your 8s are, but just general advice. All right, moving on. We kind of got sidetracked. So question 4, finding P. A certain grammar school in Sydney, won't say the name of the school, just a random school, has yearly school fees of $40,000. Once again, a random number, cough, cough. Upon the birth of their child, a certain enterprising couple figure that if they have $250,000 in exactly 11 years, in other words, when their child turns 11 years old, I suppose, about entering into year 7, then this sum should fund their child attending this school for grades 7 to 12. Given an interest rate of 6% per annum, how much money would this couple need to invest right now in order to have the appropriate sum in 11 years' time? So 11 is clearly N. 6% per annum, that's clearly R. And you want to have 250,000, that's clearly A. So we set up our equation. A is equal to P, 1 plus R all to the N. Now we want 250,000 is equal to P. We don't know 1 plus. Now we are working in years, so R will just be 6 over 100 all to the power of 11, and just divide that over 250. Like I said, this is probably the easiest one. I should have put this earlier. Doesn't matter. Who cares? So we have 1.06 all to the power of 11. And if you're not sure how I got 1.06, look, just put that on the calculator. You'll see it's 1.06. All I've done is I've just moved this, or I've divided both sides by that, effectively isolating P. And yeah, look, just put on the calculator, you get the answer. So look, I don't want to make the video too long. It's already 21 minutes long, about to 22. So that's it for this. The good thing about a video is you can pause, rewind, rewatch as necessary. And here's homework, quote unquote. Look, I'm not your teacher, but the only way you'll get good at maths is if you do maths. So, homework, I know, homework, quote unquote, just do the questions, okay? Cambridge Year 12, you can do any of them. I'm not gonna say do all of them, just do any of them. I like the maths and focus exercise, and look, I'm not a maths and focus fanboy, if that's, if you're suspecting as such. I actually use the Cambridge textbook, but I found for finance, maths and focus, in my humble opinion, and look, I'm sure your teachers and you might disagree, but in my humble opinion, I had a look at all 3 of them, and I really feel that the maths and focus questions were good. And there were more of them, there were more variety, so I would recommend doing maths and focus. If you don't have it, that's okay. You can do whatever you want. These are the 3 common textbooks, which, I'm somewhat familiar with. So yeah, do any of those. I would recommend the maths and focus one, because I had a look at all of them, and I really like the maths and focus questions for this particular topic only. Yeah, best of luck, and you can ask for help on Discord. As we always do, as you guys always do. So just ask for help here, and yeah, best of luck.